Hi, my name is Bintu and today I am going to teach you how to delete a node from a doubly linked list. The doubly linked list is also known as a two-way list because it consists of two pointers, one pointing to the forward direction, one pointing at the backward direction. So the benefit of the doubly linked list as compared to the single linked list is that it can be traversed in both the directions. You can traverse the doubly linked list in FIFO direction, first in first out, and in LIFO direction also, last in first out, that is in the reverse order of the values that are inserted. I assume that you've seen my earlier videos of creating and displaying of single linked list. That will help you in understanding the concept more better. If you haven't, please use the links shown here. Here in this lecture, I'll be focusing on how to delete a node from a doubly linked list. I'm using a structure, I'm calling it a node, and because I'm assuming that my doubly linked list consists only of integers, so in this structure, I'm using one data member called as data. It is of integer type and two pointers. One is called as next and another is called as previous. Both will be pointing to the structure of type node. Obviously, the next pointer will be pointing to the node in the forward direction and the previous pointer will be pointing to the node just behind it. These are two pointers. One is start list and another is end list. Both are global pointers. Start list will be pointing to the first node in the doubly linked list and end list will be pointing to the last node in the doubly linked list. Obviously, the start list will be helping in traversing the doubly linked list in forward direction and end list will be helping in accessing the elements of doubly linked list in reverse order. These are the four function prototypes: create doubly list, display FIFO, display LIFO and delete doubly list. This function will be creating a doubly linked list. This will be displaying the elements of doubly linked list in FIFO order, first in first out order. Display LIFO, last in first out. This function will help in displaying the elements of doubly linked list in reverse order. This is the focus of our lecture. Delete doubly list. It will help in deleting a node from a doubly linked list. When you run this program, you get a menu which will display four options to you. Press 1 to create a doubly linked list. Press 2 to display the elements in FIFO order. Press 3 to display the elements in LIFO order. Press 4 to delete a node from a doubly linked list. And 5 is for quit. So until you press 5, this menu will keep on running. It will keep on asking you the values. When you press 4, it will execute this function delete doubly list. And obviously this will help in deleting a node from a doubly linked list. This is the create doubly list method which we've discussed in the earlier video. Please do view that video and you will understand what this function is doing. In any case, when this function is over, it will create a doubly linked list of the elements entered by the user. And the first element of the doubly linked list will be pointed by start list and the last element will be pointed to by the end list pointer. This is the delete doubly list which will delete a node from a doubly linked list. User might delete any node from a doubly linked list. He might delete the first node of the doubly linked list. He might want to delete a node anywhere in between the doubly linked list. Or the user might want to delete the last node of the doubly linked list. Let's assume that the user wants to delete the first node. When this function is executed, it will check if the start list is not null. If it is not null, then it will go in if block. But if it is null, then it will go in else block. When start list is null, that means doubly linked list is not yet created. In that case, it will simply display a message that doubly linked list is empty. But if start list is not null, that means at least there is a single node in a doubly linked list. In that case, it will go in if block. It will ask the user what you want to delete. Enter the value that you want to delete. Suppose the user want to delete the first value, that is 5. That 5 will be assigned to this toDelete variable. You are comparing if the data member of start list, that is the data member of the first element, is equal to toDelete. If it is, if the user wants to delete the first node, then you are making use of temporary pointer temp1. You are asking it to point at start list. So temp1 pointer will point at start list. Start list pointer is set to move at its next node. That is where the next member of start list is pointing. The next member of start list is pointing at this node. Start list will come and point here on element 2. After that, the previous member of start list is set to null. See, the previous member of start list is pointing at this temp1. Because you want to detach this node, you want to delete this node, the previous member of start list is set to null. Can you see that? After that, you are freeing up the memory allocated to temp1 node. So you are freeing up this memory. Because this element, there is no connection of the previous pointer of this node with the temp1. Moreover, start list is pointing at this node now. So now onwards, whenever you display the elements, it will begin from here. And even if you display the elements in reverse order, it will stop here at this null. So this node, first node is deleted. What if the user want to delete some element in between the doubly linked list? Let's assume that user want to delete this 8. We will be making use of 2 pointers in that case. Temp1 will be set to point at start list. So temp1 will be set to point at start list. Temp2 pointer is set to point where the next member of start list is pointing. The next member of start list is pointing at this node, that is 2. So temp2 is set to point at 2, right? So we will be making use of 2 pointers, temp1 and temp2, with temp1 pointer following temp2. You are executing this loop for the time temp2 is not null. See, it might happen that user might enter a value which does not exist in this doubly linked list. In that case, temp2 will reset null. Obviously, in that case, you will display a message that value to delete does not exist in the doubly linked list. So this loop will execute for the time temp2 is not null. You are asking whether the temp2 data is equal to the value that the user want to delete. Is 2 equal to the value that the user want to delete? Assuming that user want to delete 8. Is 2 equal to 8? No. So it won't go in if block, it will go in else. In else block, you are asking temp1 to point at temp2. So temp2 will come here. And temp2 is set to point at its next node. Temp2 is set to point at its next node. So temp2 will come here. So temp1 and temp2 pointers are moved one node further in the doubly linked list with temp1 following temp2, right? Again, is temp2 not equal to null? No, it is not yet. Is the data member of temp2 equal to the value that user want to delete? Is 8 equal to 8? Is this the value that user want to delete? Yes. This if block will run. Temp3 pointer, another extra pointer is being used. It is asked to point where next member of temp2 is pointing. Next member of temp2 is pointing here. So temp3 is set to point at the next node of temp2. Is temp3 not equal to null? Is temp3 not equal to null? No. Why you are checking this? Because it might happen that user might be deleting the last node. You will be checking that condition also. So if temp is not equal to null, the next member of temp1 is set to point at temp3. Temp1 is here. The next member of temp1 was pointing at this 8, but now you want to delete this. So the next member of temp1 is set to point at temp3. Can you see that? This node is bypassed. Also, the previous member of temp3 is set to point at temp1. The previous member of temp3 was pointing at temp2, but now you are making the previous member of temp3 to point at temp1. So this is bypassed. Free up the memory allocated to temp2. So you are freeing up this memory allocated to temp2. So this node is deleted, and break statement you are coming out of this while loop. Because the node is deleted, there is no need of running this while loop. So it will exit from the while loop. But what if the user want to delete the last node? In that case, the control will come here. And what will happen? You are making use of 2 pointers temp1 and temp2 with temp1 following at temp2. Each time we will compare the data member of temp2 whether it matches with the value that the user want to delete. Is 2 equal to 3? No. In that case, you move both the pointers temp1 and temp2 forward in the doubly linked list with temp1 following temp2. So temp1 will be set to point at temp2 and temp2 is set to point at its next node. Again, you will compare whether this is the element that user want to delete. Is 8 equal to 3? No. Temp1 and temp2 will be moved one step further. Temp1 will be moved at temp2 and temp2 will be moved at its next node. You will again compare whether this is the node that user want to delete. Yes. In that case, you will be using third pointer temp3, which will point at the next pointer of temp2. The next pointer of temp2 is null. So the temp3 will point at null. You want to detach this node from temp1. So the next member of temp1 is currently pointing at temp2, but you will bypass that. You will set the next member of temp1 to point at temp3. So the next member of temp1 is set to point at temp3. Because this is a null node, you don't have to worry about the previous pointer of this null. But you have to move this endless pointer to point at temp1. Because this node is supposed to be deleted and this temp1 will become the last node of the doubly linked list now. So endless will set to point at temp1 and thereafter the memory for this temp2 node is freed up so that it can be used by other projects. So this is all. Let's run this program to see whether it is working properly. I'll be making use of Unix to run my C programs. For that I'm using Kigwin software. Kigwin is a software package that provides you a platform to run Unix commands on Windows. This is a program that I have already saved in Unix. This is what I explained to you right now. Let's compile this. I'm using GCC compiler for compiling my C programs. Compiled successfully, no message, no error. Let's run this. You get a menu. Obviously we'll press 1 to create a doubly linked list. Press 1, enter integer value 1. You want to add more? Yes. 2, yes. 3, yes. 4. Want to add more? No. Let's display in FIFO order 2. Let's display in LIFO order also. 4, 3, 2, 1. Now let's delete one node. Say press 4. We'll delete the first node, that is 1. Let's press 1. The node is deleted, right? Let's display whether this is deleted. Press 2. See, 2, 3, 4. So first node is deleted. Let's delete the middle node, that is 3. What is the value that you want to delete? 3. The node is deleted. Let's display. See, 2 and 4. That means 3 is deleted. Let's delete last node now. Press 4. What is the value that you want to delete? 4 again. The node is deleted. Okay. Let's see the display 2. So that means even the last node is also successfully deleted. Press 5 to quit. So this program is running perfectly. If you find any problem, you can mail me at bmharwani@yahoo.com. If you want even the code, you can mail me. Please subscribe to my channel Bintu Harwani and do write the comments, please. I'm not sure about whether you are understanding my lecture or not, and please guide me if you want video tutorials on any other computer subject also. Thank you so much. Have a nice day.